Assalamu alaikum. After I uploaded the earlier SDSM video, a lot of people have been asking on how to downscale the monthly means if only monthly means are available and no daily data is available. So after going through various softwares, I checked on Excel and I believed it to be a better solution for downscaling the monthly means by using the same predictor variables that we use for daily data downscaling in the SDSM software. So in this video I'll teach you how to downscale the monthly means if only monthly means are available. Before I start with this tutorial, would request all of you to I would request all of you to watch the earlier SDSM video on how to obtain the predictor variables from the SDSM website or any climate data website for downscaling the weather data for your area. So first of all, in this we'll open an Excel file, open a new worksheet in blank worksheet in it. Now we need to open the data files from SDSM that we have downloaded from the internet. So I'll click Ctrl plus O, go to the folder where I have downloaded, that is the box folder. In this I will be using H3A2A scenario, that is the Hadley Center model for A2 scenario that has a data from 1961 to 2099. So here you will see that there are nearly 26 files present in this folder. 26 files are present in this folder, so you need to select all of these and click the open button. In order to make this video a little short, I have already done this, so I'll be showing with what you have to do with all the files by opening only the first two files. I'll use only two files, you have to open all the files. So I'll use MSL pass and PFAS and open them. We have to click finish, again finish. You might have to click this for 26 times because the total number of files is 26. So we'll copy the data from this file p_fas, copy it, open a new book. In the first we'll write the name p_fas and in the second row we'll paste the data. I'll copy it again and paste it. Similarly for the second MSL PAS, I'll again copy the data, paste the data and then write the name as MSL PAS. I'll recommend that you paste the data first and then write the name, because when you write the name initially the clipboard gets cleared and nothing will be pasted, so you have to copy again. So please paste first and then write the name. Now I'll close the earlier two files. So this file is a file in which I have combined all the variables, all the predictors. You can see that these have the daily predictor data for from 1961 to 2099. That sums up to 50,040 observations, because the first row is the title row, so it has come up to 50,041. After we have done this, we need to calculate the averages, monthly averages from these, so that we can use it for our downscaling. So before I calculate the averages, I'll copy the titles of these columns and paste it here only for easier access. So here we'll be calculating the averages. In order to calculate the averages, I have simply wrote a script that automatically generates the formulas for calculating the averages. So I'll copy this, paste it here. so that the averages get calculated for each of the data. In order to make sure that the average has been calculated right from 1961 to 2099, I'll write the months plus the years. That is Jan 61, Feb 61. I'll select both these cells, double click at the corner so that it gets automatically expanded right to the end. So you can see that we have data right from January 1961 up to December 1999. I'll now create a new worksheet and write its name as obs predictor. That means it will have the observed values as well as the predicted values. So I'll open the observed mean, copy it into this file. For the predictors, I'll do the same, but since I have the data, observed data from January 1985 to December 2014, I'll be copying the predictors for this given range only, that is from January 1985 to December 2014. So I'll select the first column, that's for the dates, then shift control and I'll press the right arrow key such that the whole all of the rows for the selected range get selected, and I'll press the copy option. Go to this and paste only the values of these columns. Sorry, not here. I'll skip the first row for titles and paste it in the second row. So this one we don't need, so I'll delete it. And from here I'll go to the top column, select the names of these columns and paste it here. Sorry. Select this cell and paste it. I'll double click here so the whole column name gets visible. So now in the current sheet we have a combination of the observed data, that is the dependent data, and the independent predictor variables that we will be using. So as in SDSM, we screen the variables, that is we obtain the partial correlations between the predictant file and the predictor variable. Similarly here we will obtain the partial correlation. In order to do this, we'll use the data analysis toolpack of Excel. It is not, the data analysis toolpack isn't present activated by default and needs to be activated manually. So you will click on the file, options, add-ins, click go and select the analysis toolpack. I have already enabled it, but you need to enable it. So click OK and go under data, press this data analysis, press on select correlation from the list and click OK. Now you have to select the input range. In the input range we'll select the observed data as well as the predictor data and click OK. So here we get the partial correlations or the correlations between the various variables, between the various parameters. So we'll write the name of this table as correlation. In order to know what this column 1 2 stand for, we'll go to this table, the Osler spread, go to the first row, select the whole row except the year one and click copy. Go to the correlation, we'll paste this row here. Again we'll copy this row and paste it here. We'll paste the transform of it here. So people with earlier versions, that is before 2000 and 10. You might not get the options in the same way, that is, you might not see this visual option. There is the special option where you need to click and paste, select the transform, check the transform option. So here you can see that this file shows an correlation. For example, the first row shows between observed mean and observed mean, then temp pass and observed mean, then similarly MSL pass and observed mean. We don't need to check the correlation between MSL pass and temp pass, etc. So we'll ignore the rest of the column and delete these columns except the first and second column. So deleting these, we are left with only two columns. From these two columns, we'll also delete the first two rows. So we are left with only the predictor variables, that is the independent variable. Now you can see that they are arranged in a haptic manner, and thus we cannot determine easily which ones we should select or not. So I'll select the column B and sort the columns A to Z. Click sort. So you'll see that we have a now easily ascending type of correlation chart that shows the lowest correlation up to the highest correlation. So here you can use this also, but it is a negative correlation, plus you can use all of these three. So I'll be using these three only in this tutorial. You can use this one also. So I'll be using these three only, since they have the highest positive correlation. If no higher positive correlation is available, you can check whether negative high correlation is available, because minus positive correlation shows that with an increase in these parameters there will be an increase in the dependent variable, that is observed temperature, while this negative one shows that due to a decrease in this parameter there will be an increase, and due to an increase in this parameter there will be a decrease in the observed data. So we'll select only these three for our model calibration. That would be the next step in our SDSM. In the calibrate model, a regression equation is generated, so we'll manually do it in the Excel software. So we'll note the names of all these variables, that is tempas, p500 and shumas. So we'll open this combined table, select the observed, tempas, p500 and shumas, copy these columns, open a new one and paste it here. So we'll name the column as regression. And now we'll again go to the analysis toolpack, select regression from the drop down or the list and click OK. For the input range, we will select the observed mean. And for the input X range, that is the independent variables, we'll select these tempas, p500 and shumas. Okay, now we'll generate this. You can either generate it in a output range, new worksheet ply, or on a new sheet, or in a new workbook. So I'll be using a new worksheet and click OK. I'll rename this table to regression result. So after from this table we get the summary statistics, that first we get the regression statistics, then the ANOVA table, and after that the intercept and the different variables, etc. So the R square value determines us that about 87% data can be generated by just using these uh, by just using the three parameters, that is we can determine observed mean by only using tempas, p500 and shumas. 87% of the data can be only determined by these three parameters. So what we have to do with these three, we'll copy these two columns, that is 2 columns and 4 rows, copy it. But before I proceed further, I'd like you to know that if you choose 5 number of variables, you may have 5 variables, means x variable 4, x variable 5 after it. Since I chose only 3, there are only 3 variables that I have here, coefficients. So I'll go to the regression, I'll go to this column and paste the transpose of the data that we copied earlier. I'll expand this for the full column name to be visible. Now, how do we generate the model data? In order to that, in SDSM we used to generate this as the weather generator by using the pair files and selecting these and then saying the output file, which would give us the model data. But here we will do it easily by simply using these parameters that we have obtained from the regression result. So we'll go to this, write the modeled mean, and to calculate this we'll use the equation that intercept plus x variable 1 into the first variable x variable 1 multiplied by the first variable plus x variable 2 multiplied by the second variable plus x variable 3 multiplied by the third variable, and press enter. You'll notice that there is a slight difference between this modeled mean and observed mean in SD. If you have would have done the same in SDSM, you will also have got a little variation. So we'll select right from this column up to this column and double click at the corner so that the data gets automatically generated for the whole series. So in order to make a comparison between the model data and the generated observed mean, model mean and observed mean, we'll insert a column right here for the dates, that is January 1961, similarly February 1961. Sorry, I have used the wrong dates. It's January 1985, similarly February 1985. We'll drag it for the whole series such that the data is up to December 2014. After that, we'll select column A, column B, and the column K, that is the date column, the observed mean column, and the model mean. And after that, we'll insert a simple 2D line chart which shows us a comparison between the observed mean and the model mean. I'm expanding this chart only to show you the differences. So we'll see that the blue line shows the observed mean, while as the red line or orange line shows us the model mean. So we'll see that the observed mean we'll see that the model mean follows the same pattern as the observed mean, with slight differences in predicting of the in the prediction of extremes. So thus we can say that this model can be used for generating of the future scenario. So I'll delete back this chart. In order to generate the data for the future scenarios, what we'll do, we'll copy only these three parameters from the earlier table where we have combined all the predictors, that is this table. We'll be copying the averages of Tempest, P500 and SHUMAS. Click copy, click a new sheet and paste it here. After I paste it here, I'll open the SDSM to let you know that after weather generation, we generally skip these two and go to the scenario generation. So this scenario generation, okay, summary statistics we used to do here, where it would have given us the about the model that observed. So we can do it manually in Excel by simply doing this. This is our observed data and this is our model data. I'll go to the end of it and select e equal to average of this whole column, that is the observed data. Then I'll go to the model data and write equal to average and get the average of the whole column, that is the model mean. We'll notice that the average of the model mean and the observed data are equal. Similarly, we can get the standard deviation, and for that we'll use the SD, or I don't actually know this for max and minimum. I don't actually know the formula for standard deviation in, so it's standard STDEV. So I won't, so we'll use STD of population, STDEV dot P, and calculate the standard deviation for this column. Similarly, we can copy this cell and paste it here such that the formula only gets pasted and it will show us the standard deviation for the predicted or model data. Similarly, for maximum, we can use for max space bracket start, and for min we can use equal to min. So we'll copy all these and paste it directly without any paste special, because it will paste the formula such that all it gets automatically calculated for these. We'll notice that the means are same. There is a difference between the standard deviation, a little variation between the maximum values, and there is a greater bit variation between the minimum values, but since this is a model, there is such variation. So we can now need to calculate the future, generate the future scenarios. As in SDSM, we need to generate the scenarios. So I'll show you how to generate this scenario. We'll go to the predictors file, to the sheet file that I have already shown you how to paste it, and rename it, and I'll let it rename it to future weather and press enter. So in order to generate the future weather, we'll simply go to this regression table and copy the first two rows. I mean the first two rows from these columns. Copy these, go to future weather and paste it. Directly paste it. No space special is required. Double clicking to make the, I'll double click here, sorry, I'll select this row and double click at the end so that the data is generated for the whole series right from January 1961 from January 1961 right up to December 2099. That is the last step that we use generally in our SDSM software. So you can compare the results as I have already shown you how do we compare it. So after this we can do a time series analysis, that is how what will happen in the from 2010 to 20s, 20s to 30s, 30s to 40s. For that we'll be using a simple formula that I'll be uploading a video later on, as I haven't prepared. I'll be preparing a script as I don't want to do it manually. So I'll upload a script and a video on how to use the script later on. So till then, if you have any issues, you are welcome to post it on the in the comments, but I would request all of you to please watch this video at least 3 times before asking any questions. And most of the people earlier used to only ask questions without watching the whole videos. Thank you.